All right, we're going to try our best with this. So here's some of the homework right here. All right. So like I said, we're going to see how well this works. The first problem is number 11, where they just want you to go ahead and graph or find a formula. So the first one here, we see that our parent function is f of x equals x squared. And since the vertex moves 1, 2, 3, 4 units over to the right, let me make my marker a little bit bigger here on both of these. There we go. So this is going to be, in red, it'll be f of x equals the quantity of x minus 4 squared. So that's the first one. Now our next one, we could see that the parent function here is the square root. Now this shifted over to the left 2 units. So this is going to be f of x equals the square root of x plus 2, since it went over to the left. Okay, now the next problem here is going to be, oh, my phone just went off. Sorry about that. The next one is going to be number 20. So what's number 20 say? The function of f is given. You know what? Let's just go to the textbook here. Let's see if I can find the textbook. There we go. All right, so here's number 20. Oh, I got to go a little bit lower. There we go. All right. Again. Perfect. There we go. Phone's muted. Okay. So the graph of G is given. Sketch the graphs of the following functions down below. All right. So here, all right, in part A, we want y equals g of x plus 1. So in this situation, the plus 1 is contained inside of the function. So which means we're going to have to shift everything to the left 1 unit. So for example, and I'll use a different color here. Let's use, we'll use this nice blue. So all I'm going to do is shift everything to the left 1 unit over. All right, so like, for example, that's that point, that's that ordered pair, that's that ordered pair, and then here we go. And now, there's our new line right there. So that's the first one. Now, for part B, not only do we have that shift to the left, but we also have a reflection about the x-axis. All right, so the first thing is we want to do the reflections first. So if this is the point, let's see here, what's that? -1, -2, -3. So if this is -3, comma 1, 2, -2, all right, then when we reflect this, all right, it's going to be -3, comma +2. So it goes up here now. All right. This ordered pair right there, all right, since that is 1, comma 2, this is not going to be 1, comma -2. So it's going to go right here. The next one's right here. And then this one's right here. So first, here's our reflection. That's our reflection right here. So this is -g of x. But now we have to do the +1 part, which means we have to shift it over to the left. So let me go ahead and get rid of all this. So now this point goes over here. This ordered pair goes over here. That one goes there, and this one goes here. So if I just get rid of all of this, now we have this graph. And that's what it looks like. So you got to remember, you got to go in the order in which we do these shifts and everything. Okay? So I'll do a couple more here. So let's do, I'm going to do part D here. This one's pretty straightforward. With this, all we have to do is shift everything up 2 units. So there's my new ordered pair, that one, and that one. So now it looks like this. Oh, it's -2. Sorry, everybody. Hold on. It's -2. So it goes down. There we go. There we go. So that's g of x minus 2. Okay. Let's see. What is the next question here? Number 27. Let's go look at number 27. So a function of f is given. The indicated transformations are applied to the... Okay. So another transformation. So here we go. All right. First, let's write out the equation. So we have f of x equals, now we know it's parabola. It's shifted up 2 units and to the right 2 units. So there we go right there. So that's pretty straightforward. And then, did they want us to graph this? Write the equation. Nope. So that's all we had to do. All right, so that one's done. Let's try another one here. 31. Here we go. All right, so we have absolute value shifted to the right half units, shrink vertically by a factor of 0.1, and shift downward 2 units. All right, so we're shifting to the right. So that's going to be x minus 1/2. Now we want to shrink vertically, okay? So the thing we have to remember here, everybody, are the stretches or the shrinks vertically part. So if you remember, I'm going to write over here to the right. If c is greater than, let me write this out first. There it is. So if c is greater than 1, it's a stretch. And if c is in between 0 and 1, then it's a shrink. So what I'm going to do is I'm going to rewrite this as f of x equals, and we want to shrink vertically by a factor of 0.1. So 0.1. Then we have the absolute value. And finally, downward 2 units. So there we go there. So it's just a matter of, excuse me, remembering our definitions and everything. So that was 31. Let's go ahead and let's look at 34. All right, so 34 says sketch the graph, not by plotting points, but by starting with the graph. Okay, so this is just straight up. This is just straight up sketch. Doesn't have to be crazy good or anything like that. So here's the parent function here. All right. And we want x plus 7 squared. So it's going to move to the left. 1, 2, 3, 4, 5, 6, 7. And there it is right there. So this is just give us a sketch. Okay. Now, I think what would be really good is if I started using like Desmos, because I could then kind of explain like what I would like to see like on a test or something like that. So let's look at number 40. Okay, so here's 40. All right. So let me get, I'm looking at my other monitor here so I can get these questions. All right, here we go. All right, so number 40. So number 40 is y equals 2 minus the square root of x plus 1. Okay? So this is what we know it looks like. All right? But let's see how this kind of gets to where it is. So we're going to turn this off real fast. So the first thing is that parent function. Y equals the square root of x. Okay? Now, if we think about this in terms of like the process in which we do this, we identify the parent function, then we do stretches, or then we do like reflections, right? So we know we have a minus sign out front. So let's put a minus sign out front. Now we get that. Okay? So then we worry about stretches or shrinks, but we don't have that here. Then we worry about translations horizontal or vertical. So let's do the +1. And then finally, we'll put that 2 out front. And that's how we transformed the square root of x, which is in green, and I'll change this to like red with like the little dots. So that's how we take the parent function and then we translate it, okay? So like on a test, this is like something I would want to see right here, all right? It's just maybe identify the parent function, and then from there, go ahead and show the graph. Now, sometimes this can get a little bit more complicating. Oops, sorry about that. Let's do this. There we go. So what do I mean by this can get a little bit more complicating? Well, let's look at number 44, okay? So number 44 is the parent function is going to be x cubed, all right? So that's our parent function right there, okay? Now, the transformation equation they want us to do is y equals 1/3 x to the third minus 1. All right. So in purple is what we want. So what I think would be like so awesome, all right, if you could do this for me, is if this were a test, and since this is strictly a sketch, and I'm going to show you what I want. Oops, there we go. All right, first thing is identify this parent function in red. That's best. If you want, you could even write like parent, okay? Then the next thing would be, say, like a little arrow down for the shift down. You could even highlight that. Shift down 1 unit. All right, and then to talk about like the 1/3. See, it's really hard if you don't have ordered pairs or anything to see like the stretch that we're doing here. All right, so just identify it. That's, I'll just label stretch, and then I know that just by looking at this value right here, you recognize it as a stretch, which means all of these ordered pairs are going to be stretched out, right, in the y direction, and that would be perfect for me. Okay. Now let's go ahead. Let's do what number? 60. What's the next one? 67. Okay. So 67 is even or odd stuff. So we have f of x equals 1 minus the cube root of x. So we already know, oh, sorry, let me label this 67. There we go. 67, haha. So f of x equals 1 minus the cube root of x. All right, we already have f of x. That's done. What we need to figure out is f of negative x. That's what we're looking at here. So substitute negative x into the function. All right, and we know that the domain for cubic roots is negative infinity to positive infinity. So that negative can come out. All right. And when we look at this here, notice that we do not have exact opposites. In other words, there's no definition that we can fit here. So this is not even, nor is it odd. All right. The next one is 63. I'm going out of order because I wrote them down backwards. Next one is 63. So let's look at 63. So f of x equals x squared plus x. Now, f of negative x. So here, a negative squared is always going to be positive. All right, and this just turns out to be x squared minus x. And if I wanted to, I could try to like factor out a negative or something like that. But at the end of the day, you have x squared plus x and then x squared minus x. So there's really nothing you can do here either to figure out if it's even or odd. So even or odd, neither. In fact, even if we went and we graph this, so let's go ahead, let's graph real fast. So we have x to the second, oops, plus x, and then x to the second minus x. So notice here it was just shifted over. Like it's not even nor odd, it's neither. Okay? Now let's look at 65. So 65 is f of x equals x to the third minus x. Now if I do this, and we do negative x, let me write it in red. So I put a negative there and a negative there, then I simplify a little bit. So I end up with f of negative x equals negative x to the third plus x. And if you look at what we have here, this is really important because what I can do is I can factor out a negative 1 to get me right back to where I started if you look directly above. And you see how these are like the exact opposites of each other? This is that f of negative x equals f of negative x. So this is odd, 100% odd. And we can go ahead and verify that just by graphing it. So let's go ahead and let's graph this. So first one was x to the third minus x. And then this turned out to be negative 1, parenthesis, x to the third minus x again. And you can see just like how they're one is like reflected about the other. But more importantly, you have that line of symmetry thing where, let me see if I can copy and paste this and show you what I'm talking about. So we'll look at like this ordered pair right here, and then this down here, and then this right here, and then this right here. Notice in the book they had like a really cool picture of this, which I'm going to go to real quick. This thing right here. Use this color right here for the next one. And do you see how like they're like perfectly symmetric? That's how we know they're odd. Okay. And I hope this helped with the homework. Remember, I did 67 first by accident. That one's right here, and this one was neither. Okay. And I think that's it for now. So I will see you in the next one. Now I got to find the right thing so I can stop the recording.